Hey, it's great to be here after 5 years. I guess it's been 5 years. A lot has happened. A lot has changed. I'm very thankful that Paolo made DTN 1. So many people met or got closer through that conference. It's been amazing to recreate that experience now, and I look forward to having DTN 3. Hopefully not in 5 years, hopefully like sooner. It's really an amazing conference, so thank you, Paolo, for making an amazing community. So what I want to talk about today is a quick summary of what happened between kind of DTN 1 and DTN 2. I'll just give a few highlights. And the goal there is to give you a sense of how large projects come to be and how roadmaps really help get there, meaning really big change takes a while to affect in the world. But just as a snapshot, you'll see the difference between, hey, in DTN 1, where were we in DTN 1, as Paolo was saying, hey, yeah, we'll see. And now, kind of what we've achieved so far. Of course, there's a long road to go still, but being able to reflect on progress is very useful. I think I've seen over the last few years, just people get excited and not excited about the DWeb. But the thing to remember is just sometimes how long computing infrastructure changes take place, right? So in the large scheme of things, it's really fast. In the slow scheme of things, or in the small scheme of things, it feels really slow sometimes. So here's like the logo for DTN 1 from 2015. This is like slides that I pulled from that talk. I'm probably to blame for everyone using this thing now. I would popularize it a lot, and so yeah, if you have a problem with this diagram, you can blame me. So at that point, I talked about trying to create a web of Merkle links. So being able to hash link data structures, hash link files, and then if you can hash link files, then you can hash link websites. And if you do that and expose it to the browser, suddenly you have a web that is all content addressed. I also talked about being able to explore all the hash link data structures, and instead of having a single Merkle tree, create like a Merkle forest, and you would be able to like go in and explore the Merkle forest. And everyone was like, you're absolutely crazy. What are you talking about? At the time, I also talked about the IPFS stack, and I pointed it to these other projects. I had a thing like this that broke out to like a stack like that. And at the time, IPFS was sort of kind of a mishmash of all of these things together and kind of a single monolithic system. And we just, one very significant thing we did since then is we split it up into pieces. One of the big points along the way was to recognize that all these pieces were separable and to instead extract whole components out of IPFS and create their own projects. So probably one of the most important and most successful things we've done along the way is to recognize those boundaries and then split them off into other projects where people can adopt the pieces that they actually need and not necessarily have to depend on the whole thing. This has been pretty successful in a bunch of contexts. There are things that do not need IPFS, but that do use things like lib2p and so on. And so we, in general, believe in creating a modular, reusable, unbundled stack of being able to recognize when a project is trying to do too many things at once and then splitting it up into pieces. So we've been accused of doing that too much and too little. Can't really please everybody, so we'll try to draw a line in between. So with that, I actually wanted to, instead of talk about all this stuff, actually invite some of the people leading these projects to give you a little bit of a brief on what they are. So Mike, do you want to mention a bit about lib2p? And you heard about lib2p in the morning, but you hear a little bit more.
Hey, my name is Mike Gelzer. So I'm from Protocol Labs, but I co-lead lib2p along with my partner in crime here, Raul, who you'll hear from a little bit later. So I just wanted to explain a little bit about what lib2p is, because listening to a lot of the talks in the past 2 days, I actually think this could be helpful to a lot of people. So let me explain the motivation behind it. When you want to build a peer-to-peer application, you're first starting out, it looks pretty simple, right? You just need to get some network connectivity between the different peers. And it turns out it's much more complicated than that, because then you start to want to use a single connection between peers to multiplex different protocols or different data streams. And then you want to have those be encrypted. And then you get into well, how should I do the cryptography? Should I use, ED 25519? Should I use RSA keys? So there's like a lot of complexity in building a robust peer-to-peer application. So what libp2p is fundamentally is a set of building blocks that you can use in your own applications in a variety of languages, as we'll see in a second, that make it much easier to build peer-to-peer applications that are really robust and support all the features you'd expect, like encryption. I think I put that down as encrypted channels, multiplexing connections, multiplexing streams, peer discovery. So how do you find other peers? We have a distributed hash table. We have actually a couple implementations of this, but we provide you with these building blocks. NAT traversal is another one that we're building that out. But if you try to actually build a peer-to-peer application, you're going to discover a lot of your users are behind NAT routers, and that makes things substantially more difficult. So, and PubSub, another primitive that you want to use in a lot of applications to send simple messages between nodes. And so we're basically providing all of these for you, but in a modular and composable way. So if you don't want a DHT distributed hash table in your application, you don't have to use that. If you don't want encryption, you're not obligated to use it. So everything is composable and pluggable. Here are some downstream adopters. This is an incomplete list, but these are folks who are using some parts of libp2p. And I won't dwell too much on that. We've had a lot of growth in the community. I think unique user here means if they open an issue, they open a PR, like any kind of interaction with the project. And the other thing I wanted to cover, I don't have a lot of time, but we started implementing libp2p in multiple languages. So originally libp2p was written just in Go and JavaScript. And that was those were the two implementations. And there's a spec that defines how they're supposed to work together. Since then, though, there have been a bunch of other implementations. So you heard from Pierre this morning. He is probably the primary developer of Rust libp2p, which interoperates with the other two. And then more recently, we have Pi libp2p. We have a couple of people tackling the JVM in either Java or Java dialects like Kotlin. And then we have a C++ libp2p, which we're very excited about. Many of these come from grant funding, either from, and I missed actually Lua on here. That's another one that's being developed. So many of these come from grant funding, either from Protocol Labs or the Ethereum Foundation or the Web3 Foundation. That's the foundation that Parity endowed. So there's a lot of interest in implementing this in multiple languages, which is great because if your application is already in C++, then you probably don't want to have to worry about compiling in another language like Go. Those are the end of my slides. So just to kind of wrap up though, the fundamental theme here is like these are composable building blocks. They're available in many languages. And it's battle tested in IPFS, which means we know it has some problems, but we know what they are. But we also know it fundamentally works. It's battle tested in IPFS. Ethereum 2.0 adopted it. I know that there's differing views on blockchains here. We're agnostic on what users want to do with this technology. We just want to put it out there in the world, make it the best peer-to-peer stack. But Ethereum 2.0 is going to be based on this. And a bunch of other projects that are too long to list, but you can watch the video and see that slide. So, all right. So thank you very much.
All right. So IPLD. Oh wait, we have one more slide. That's actually better. So IPLD is where we build the data structures for IPFS. It sort of came out of IPFS. You saw that earlier from Juan's stuff there. So where IPFS is representing file data, we're thinking of like really all other structured data, which is a large range of use cases, many of which are actually like have already been represented in other talks, right? So there's a lot of overlap in the data structures that we're building and the data structures that people are doing in DAD and Hyper, all the hypers, and everywhere else. So I think that where it'll be sort of interesting to this audience to hear about IPLD is in the bigger kind of point of differentiation between IPLD and other projects. And that's really in how, really everything in Protocol Labs, but in particular IPLD, thinks about addressing. We think about content addresses as being global content addresses. This is how we build like a global web of things that are connected together. Whereas traditionally, a content address was an address within a namespace. So it's an address in a database or in a Git repository or in a blockchain for that matter. So what we're really trying to do is enable people to create these really big structured data people build applications that then generate structured data, and then other people build applications too that generate more structured data. But that data can actually link between each other, right? We don't have to have data in silos anymore. We don't have to build them in centralized databases, because these primitives are allowed to link within each other. And then I can replicate all of my data to wherever I care about it, and it's also linking to your data that's just in this global decentralized web. Why I think that this is important as a point of differentiation is that we need a better incentive for people to move to these models than we currently have. If offline and sync were good enough incentives for application developers to move to that model, PouchDB would be way more popular than it is. It turns out that like people are often willing to sacrifice that for the benefits of centralized databases, whether that's just that they know more about them and there's more tooling, or there's more people that you can hire to run them for you, or whatever. There's a set of incentives there that are really keeping people in older patterns. And if we want them to move to these, we need to think about like why they would do that. The incentive that I think is the most interesting and that I'm sort of betting on, to quote Pharos, the one that I'm betting on is the same incentive that allowed the web to win, which is that when you can publish a website and I can publish a website and they can link to each other, the value of the web is no longer your website or my website, it's the value of the network as a whole. And the fact that we can leverage all of the value between each other's applications and each other's data structures means that there's a huge incentive for every new application to then leverage all of the data that's been generated before. So that's IPLD in a nutshell. We're on GitHub under IPLD. Come check us out. And now I think it's back to, wait, is it back to Juan or no? Okay.
Hello, my name is Pooja, and I am one of the project leads of Filecoin with Juan. So to touch a little bit about, so I'll talk a little bit about sort of the genesis of Filecoin, and at the end sort of give like a brief progress update of where the project is today. Really like Filecoin was founded for this reason, to create a decentralized, efficient, and robust foundation for humanities information. There are a couple of problems that Filecoin as a project tries to address. One of the actually early genesis moments, motivations for Filecoin actually came out of some of the usage that we were seeing around IPFS and a lot of the needs that members of the IPFS community were expressing, like this desire that if you want to build truly robust applications on the decentralized and distributed web, you need some way to actually persist data beyond, someone's like voluntary altruistic motivations will maybe encourage them to do out of their own volition, right? So, there are many different projects that Protocol Labs spun out in order to address this problem. But one of the key ways that we thought we could address this was by building an incentive layer into a distributed file system and storage network. There are a number of problems that Filecoin now, as we've been mulling on this problem and thinking about how to build this protocol, there are a number of problems that Filecoin, we think, will address. And these are true problems that exist in the world of computing infrastructure today. We have, like, most of the applications on the internet today are built on the centralized cloud infrastructure. We think that if we want to move to this model one day where we actually do truly have a decentralized web, building what that decentralized cloud infrastructure looks like is still an open problem, and that's something that's like really important to solve. And Filecoin, we think, is going to be one of the key building blocks in order to get there. Another problem that we think is also important is there are many applications today that exist in the world that need some way to verify. There's some file or data that exists in the world that some users will want to be able to demonstrate that there is, that this data set was actually stored in a particular place at a particular time, and it has like a time-stamped verifiable proof of storage associated with it, which is something that Filecoin also addresses. And I'll also just mention, one more of these, which is so one of the ways in which we thought it was really important to construct the Filecoin protocol was really to have it be this sort of storage marketplace. So they're just like many other marketplaces that have enabled efficiencies, and the way that markets do, they enable certain like latent resources that existed, that have existed for a while, but maybe haven't really been, there's no market for it, and so they haven't really been utilized. Markets enable those resources to be shared with the world in a really efficient way. And so, we think that one of the things that Filecoin will do is make it possible, because of just like market dynamics, for a lot of this storage to be available at really competitive prices. That again will one day like allow us to actually unseat some of these centralized cloud providers and build that decentralized cloud infrastructure that we are interested in supporting and leading to. And so this is I just wanted to talk briefly about sort of what at a high level, how Filecoin will work, like what who the main players are in this network, and how the system works. So you have clients on the left side of the screen who have data sets that they want to store. Then there are, in our like sort of the supply side of this network, are the miners who provide storage to the clients, and there is the network protocol that sort of mediates the interactions and transactions between both sides of the market. So that's what I just mentioned. So what will happen is, a client will basically, over time, like propose a storage deal to some entity on the supply side of the network, to a miner. And if that deal is accepted, the miner will be asked over time by the network protocol to generate proofs that they are continuing to store that data as expected. And if that happens, then the miner will be compensated in Filecoin. So in order for this to actually work the way that we need it to, not having one centralized entity control all of these interactions, clients need to be able to trust that the network is actually doing its job. And so, yeah, so this is because like if there isn't like some trusted central party in the middle, how do you know that there isn't some malicious miner somewhere that is pretending to actually store your data, generating a proof as needed, but is actually doing some, like cheating the network in some way just so they can make money on this network? And similarly, there may be like malicious clients on the other side of the network, and miners want to make sure that they're not being cheated by clients either. And so, okay, that's it. But essentially, in order for this network to work, there's been a lot of research that our team has been doing into different sorts of cryptographic proofs that will enable these transactions to be trustworthy in the long term. Lastly, one of the key things that I think is like really exciting about Filecoin is just that there's this like graph on the bottom left, which just shows like sort of the explosion in hash power on the Bitcoin network over the last like 10 years or so. And what this really shows is, like we have all these images as well on the screen of just hard drives and data centers and latent storage. We believe that, so through some of the analysis that we've done, there is so much latent storage capacity in the world that currently isn't being utilized at all. It doesn't exist. It's not like it does exist. It's not on any of like the distributed file and storage networks that we use today. It's like this latent capacity, and Filecoin, we think, is like one opportunity to bring all of this capacity online, and it could be a really powerful mechanism to be the backbone of sort of like the distributed web that we want to enable. That's the last slide. I just wanted to say, so like Filecoin as a concept sort of was born into existence like 2 years ago, I believe at this point, or officially. And since then, we've launched a developer network, and we now have sort of an active and growing GitHub community as well. We have, like places online where we'd love to just talk to anyone who's interested in learning more about how Filecoin works, or if your application could make use of Filecoin. That's like by far our biggest focus right now, in addition to obviously getting to launching the network for real. But yeah, thanks. We'd love to chat about Filecoin at any point. Thanks.
Modularity matters, and I think as you see, these projects have large-scale goals and overlapping communities, but also disjoint communities. There's all sorts of people that care about one or other projects. So yeah, definitely check them out and work with us if you're interested in any. I wanted to reflect a little bit on IPFS progress and impact. I've used this kind of set of goals to talk about IPFS: emerging networks, inefficiency, bad security model, links breaking, no offline use, and censorship being an issue on the internet as kind of a set of goals for IPFS. If I were to grade where we are at right now, I would say that in emerging networks, we haven't quite done as much as we need to. It's sort of usable, but not nearly as well as it should be. In terms of efficiency, we've made some things vastly more efficient and created some other inefficiencies, so we kind of like get a middle grade. On the security model, same story. We've created significant benefits to integrity and authentication of content, but we haven't yet landed private content, and so that creates some kind of like in the middle of the road solution, right? So we have improved some things, but we haven't landed a better secure model in full. In terms of links breaking, so good news is right now I've seen so many examples of people adding stuff to IPFS, losing it, and then later finding it again and links coming back online. And that's an amazing feeling. Like some link goes down and then magically works again. It's pretty amazing. But in terms of the broader web, that we still haven't had a significant impact on links not breaking globally. In terms of offline use, we're sort of, again, in the middle. IPFS can be used offline, can show you offline applications. You can connect to other peers, but the usability there is so abysmally poor that only developers can really do that. So we're nowhere near where that needs to be. The thing that surprisingly, because we didn't really focus on it, we're doing really well on is like the censorship resistance piece. It's not actually that censorship resistant when you really look at it. There's all kinds of ways to attack protocols like this. But for the most part, it's so much better than everything else out there that IPFS has started to be used for major, significant censorship resistant needing efforts. And that came to us as a surprise to us. So when I talked about DTN last time, I talked about this goal of having some way to address content and then map that into content addressing and have that be a reality. This works now. This is like you can go and do this, and it's pretty sweet. In terms of platforms, we've seen experiments with a whole bunch of different platforms. Desktops on the web are like well covered. Servers well covered. Mobile, it's sort of there, not quite there. We have a bunch of like really good experiments that work already, and we have the first few applications that are doing this for real, but it's not yet so easy that any mobile app developer can do it. IoT, not quite there yet. VR, we've seen a bunch of cool experiments with VR, but again, it's still kind of hard for people to use. One of the things that I like doing is showing the upgrade path, and I've been showing this slide for a few years, and watching it, one of the best things is watching a roadmap kind of flesh out and happen. So when I started showing this, I think we were over here. Yellow was here, and like every year we've added more and gotten closer to the full goal. And from my perspective, this happened so much faster than I expected. When you set off to create a protocol that is going to work with the browser, that seems like a daunting, almost impossible thing to do. At least it did look like that 5 years ago. But now we're drastically closer to that, and you can have a pretty seamless experience on a browser using IPFS. In terms of the OS upgrade path, we have a lot of tooling in place, but we don't yet have kind of IPFS as an OS level service. Sure, you can download it from package managers and kind of install it and so on that way, but it'd be really nice to have it integrated with a bunch of tools in place so that you can start using content addressing natively in an operating system. Oh, and the long-term goal is to have an operating system on top of IPFS, which is a whole deep rabbit hole of thinking that you can get into, where you start modeling all of the file system of an OS as content address links on top of IPLD, and then you can migrate your entire OS through the network. Not going to explain that. In terms of mobile, we're somewhere in the middle as well. We've gotten things to work in mobile web, and there are some tools that have been shown to work in iOS and Android, but not yet, again, so easy that most mobile web developers can use it. I'll just go through a few kind of example things that have happened since last ETN. A lot of important data sets are being archived and distributed with IPFS. IPFS is used all over the DWeb and Web3 ecosystem, or different components of the stack that came out of IPFS. There are a whole bunch of DWeb apps that build on this. I highlight these. I think DTube is probably one of the largest user, by monthly active users, application that uses IPFS. A range of interesting work that we've gotten into is CRDTs. So being able to do real-time collaborative peer-to-peer apps that work entirely distributed. Think of Google Docs, but with no servers. There's just different peers interacting with each other. There's a lot of very interesting hard problems here, especially when you throw in an encryption. So there's a whole set of open problems there of how do you do these kinds of real-time peer-to-peer apps with encryption baked in. That is a non-trivial effort. There's things like how do we do private content correctly? So there's really good examples of this. I think I'll call out Textile and Pyrgos as two applications that have pioneered this. But this is not yet kind of baked into the protocol, so we're kind of somewhere in there. We've done a bunch of interesting work with package managers. You'll see some more of that soon. Here's one example of the kind of stuff that censorship resistance that has happened. I think this was in 2016 or 17. I think 17. Turkey blocked Wikipedia, and then we put a whole archive of Wikipedia on IPFS, and then it was immediately accessible and used in Turkey. And so this is the sort of thing that you can download and distribute locally. This was a huge surprise to us. If you remember the referendum in Catalonia, this was a very important moment for Spain and for all of the Catalans that want independence. There was a very significant conflict where the Spanish police effectively seized all kinds of internet infrastructure and tried to block all the access to the polls. This happened completely by surprise to us. People put the polling station's website on IPFS and distributed it that way. We woke up that day to the president of Catalonia at the time tweeting out a link to IPFS. Link to the gateway, which was subsequently quickly blocked, but people could use other gateways, and people could also use just IPFS to access it. But this was a pretty significant wake-up call for us because it showed, hey, people with real significant censorship-resistant use cases are starting to use this tech. And so that's a significant thing. More recently, the Mueller report WikiLeaks included an IPFS hash as part of their leak of the redacted, not unredacted Mueller report. Now, more on the lighter side, not quite as intense politically, although it could be. I don't know. Different VR systems have started playing around and using IPFS. Decentraland is one great example. By the way, if you haven't seen that project, go check it out. It's pretty amazing. Same thing goes for Janus VR. In terms of browser support, so there's kind of an extension that you can use and connects to your local node or runs an embedded JS node. This makes a lot of the IPFS experience in the web just work really well. There's an integration with Brave. There's service workers, so you can use that directly. And there's handler support through, again, the extension, and libdweb, which is an awesome project that Gonzalo, who's I think here, has been creating. And so libdweb is awesome for all of us. It really helps us be able to actually hook into important things we need to make peer-to-peer applications work. In terms of OS support, IPFS has gotten to a point where you can have like an installed application with like a GUI, really nice GUI actually, where you can see and manage your node and manage files and so on. And probably the most important thing that has happened in the last 5 years is just a massive community that has formed. Tons of people around the planet are working together, using this stuff, contributing, and that has been amazing for me and for everybody who works in IPFS. It's really humbling to see this project and this need strike such an important chord with so many people and be part of a group like that. And here's like a diagram of kind of where people tend to be in our community. We clearly need to go to a whole bunch of places in South America and Africa and maybe Central Asia and get more people on board. Though the cool thing is, if you see like the actual peers, you can, in the web UI, you can go and check out the peers and their location. You see people all over the place. I think the only continent we haven't seen is Antarctica, but we'll get there. So wanted to talk a bit about what's next for IPFS, and with that, I'm going to hand it over to Molly, who's leading the project.
Awesome. So looking forward, there's, as Juan was saying, so much cool stuff that's been happening in the IPFS ecosystem and all of the awesome, amazing projects that we collaborate with, both like the different layers of the networking stack, stuff built on top of IPFS, and like the wider space of all these amazing applications building on top of IPFS to do all this wonderful end user visible stuff. Something that we spent a lot of time on this past year when we were looking forward into 2019 was actually kind of widening our viewpoint and taking a higher order view at where are we headed? Like, what are these goals? Juan talked about a lot of them that motivate us, but we hadn't actually spent a lot of time writing down our mission statement, and using that to kind of prioritize where we're spending our focus in the year. And so that's something that we did in kind of like October, November, December of this past year, was going and creating a roadmap that's available on GitHub, which lists all of our future visionary goals. Really not all of them. There's only 16 visionary goals so far for the project, which obviously is way too few. We need to generate more of them. They definitely exist somewhere. We just haven't spent the time to write them all down. We're trying, but there are so many goals that we're shooting for as a project, and obviously we can't achieve every single one of them at once. That would leave us way too kind of our focus spread on too many different things. We wouldn't end up getting anything that we could ship to people that would solve the actual problems that real people developing on top of IPFS are experiencing today. So through this, we were able to get a better picture of what this full view of IPFS solutions look like, and use that to prioritize where we're spending our time. And so this kind of led into being able to do a sorting function on top of these visionary goals, understand how they build on top of each other, and the best course we can take through these different visions of the future, so that we're building on top of the work we do each quarter. So our top goal for this year is being able to do a really great job solving the needs of package managers. And the reason we chose that goal, because I think a lot of people here are DWeb enthusiasts, and they're like, oh, package managers, that's like maybe a little bit outside of like our normal sphere of what we're thinking about when we say DWeb. The reason to choose that is it does amazing things in terms of getting us to a level of performance and production readiness and stability and scalability that hit all of the same needs and use cases that everyone building the decentralized web needs in order to be successful. But it's more a little bit closer to us in terms of all of the use cases and kind of end user functionality that we want to offer. DWeb is huge. We cannot accomplish DWeb this year. We all need to be working on this together and building towards that. And so this is kind of chaining our progress into the future, building on stuff incrementally. So to kind of dive into what that incrementally looks like, we kind of broke our roadmap for this year down into, I think, like six epics, which talk about production readiness and package managers, kind of what I just talked about, actually making this tangibly valuable, talking to all of these communities, understanding the needs and use cases, and having benchmarks that we can use to understand, are we actually meeting those needs? Like, let's iterate, let's evaluate where we're at and make sure we can make tangible improvements for this group. There's also a lot of scalability that comes in there. There's a lot of people who are using package managers and that rely on it all day, every day to be able to be doing their development work, and that involves a lot of scalability and reliability improvements that are super important, again, for getting to this production readiness. And so a lot of this involves also figuring out how to scale IPFS, both kind of on our ends, making sure that it's supported, but also working with lots of people throughout the community, the package manager community and other communities to find ways to make IPFS more useful, maybe in contexts where we didn't see it being useful before, or people hadn't even thought of it as solving a problem that they actually had. They just didn't understand how IPFS could potentially come in and solve those problems for them. There's a number of other things that we're working on, performance improvements, getting the community together, a lot of our own support and growth. But that's kind of what our focus is for this year. And I would say, like, of these things where we're at, we're kind of in the midst of production readiness, performance improvements, like, deep in the weeds of like how we actually go and implement this stuff, with a number of conversations in the works with package managers, either people who are actively implementing this in the community, package managers who are working with us, or people within the IPFS community that are building demos and awesome things like that. So yeah, that's actually what I was going to say here. Lots of performance improvements. Lots of stuff's been shipped in Go and JS IPFS. Kind of the experiments are working on figuring things out, building some best practices and making sure that we understand where the pain points are. And then in general, lots of collaborations and connections with the community, now reaching over millions of monthly active users, which is super cool, but also something that like we need to continue, like making sure that IPFS is super reliable, given that there's so many people who are actually depending on it for real use cases. Looking even more forward, package managers continues to be like a big goal, and we still have a lot to do here. So there's a lot of critical performance improvements coming in stuff like BitSwap. There's work being done to kind of improve IPNS in a number of different fronts, which hopefully you've talked to some of the people here about. It's an area that like we know is super important, is to have those mutable links on top of all of the content addressed files within IPFS. And so that's definitely an area that's important for package managers and obviously for everyone else. So again, you can see how these have high overlap in terms of what we're doing to achieve these goals. Working closely with the community of package managers, looking at IPFS as storage, transport layers, and also looking at best practices. So, there's many different pieces of how you might use IPFS in a package manager. You can use it for content. You could use it for kind of offline indexing. You could use it for offline publishing. What might that look like? So there's really cool, interesting questions to chat about there. And some good research and best practices that we're actually figuring out and taking lessons from research to figure out how we should do this most effectively. Cool. I guess I'd also point out that like having this really great use case gives us a lot of feedback. It helps us have real users who are trying to use this in a way that we can go and understand what's happening, fix bugs, and the package manager community is amazing. Like they're being super like responsive and helping us understand, like getting involved, getting their hands dirty, and helping us figure out how to make it better for them, which is really nice and something that is also helping us from a kind of an ecosystem perspective, like make fast progress. I guess this is my last slide in terms of upcoming milestones, and there's too many things to list. But I would say that kind of the progress that's being made here continues across many fronts. Even when we have like a single use case that we're focused really deeply on, it goes across all of these problems that it's solving for people within the community. I guess some things I'd call out here is like there's a lot of awesome work around the DHT that's happening, which we really need and we're super excited about. There's GraphSync for syncing large graphs, which is also super fun. If you want to learn more about that, go talk to Eric in the back. And then there's a lot of work to also make this more usable in web browsers. There's lots of like base 32 by default stuff so that you can access all of your wonderful IPFS content in web browsers. So I guess in general, all of this stuff is super available on GitHub if you want to go check it out, or you can ask me about it, or you can ask really anyone else here about it because they probably know even can point you to your local IPFS node human who can tell you a little about what they're doing inside their IPFS working group.
Come camp with us. So this year is the year of camps. And there's, first off, coming, I think closest, is IPFS camp. We're having a camp in June 27th and 30th, we're in Barcelona. So IPFS camp is a whole 3-day event and like retreat event with a lot of the core devs of the protocol and a lot of people building pretty significant applications. We want to use this camp to solve problems together, hack on things together, increase knowledge about all kinds of parts of the system and to build a pretty strong community. This is very much inspired by No.2 actually. So thank Mikeal. This is kind of like the feel for IPFS Camp that we want to get. So if you have been to No.2 and want to experience like that, but in the DWeb, come hang out. Also, second camp that I'm going to pitch you is the DWeb camp. That's even more DWeb campy. This is in July, so if you can't make it in June, come hang out in July. This is put on by the Internet Archive and a lot of volunteers that are pulling the community together. And this is not in Europe. This is in the US. I think around SF. This is also going to be a retreat. I think 4 days and so on. The next camp that I want to talk to you about is the Chaos Community Congress camp, very close to here. These are pictures from 2015. If you have never been to CCC camp, you've got to go to at least one. It is an amazing, amazing experience. A lot of us here were there in 2015, or I guess 16, maybe it was 16. And there's a picture of that day, like rainstorm with like LED camps and like just all of these tents are filled with technical equipment and people soldering and people like making robots and people like hacking on stuff. It's pretty amazing. So come hang out with us and come camp with us. That was like the biggest part of the talk. I have like a couple things I wanna reflect on, and I wanna give you a sense of roadmap here. So there's a long way to go for all of the stuff that we're working on to be good enough for users, for like end users. It's good enough for us maybe, but not good enough yet for like end users. But just reflect on the history of hypertext. The Memex paper that was referenced earlier, 1945. Hypertext is an idea, got invented in 65, Ted Nelson and so on. NLS, the online system from Engelbart, was 67. Xanadu was 70s, 80s, 90s. Enquire, which I believe was Tim Berners-Lee. This was 10 years before the web. Tim Berners-Lee was already working on hypertext stuff. There were a bunch of other things like Intermedia, HyperCard, and so on, all the way before the web. So this stuff takes time. If you got into the DWeb thinking like, oh yeah, I'm going to work on this in like 1 year, it'll be perfect. No, it's going to take a while. I'm actually amazingly surprised at how much progress we've made in just 5 years. And so the thought is, pick carefully what you're going to work on year over year, and find important improvements that you can find motivating, solve problems for users, and then kind of ratchet up from there. And we'll all be together over a convening set of years, so also grow the community. And just take inspiration from Tim Berners-Lee, who's been at this for like decades, trying to improve tech for people. Now the next iteration is solid. And so with that, I'm going to give you some open problems that you might want to think about and you might want to consider for next DTN. I would love to see some of these solved and improved for DTN 3. First one is connectivity. We have like good setups in terms of desktops, browser, servers, mobile, and Internet of Things. But NAT traversal is still kind of flaky. Relay is still kind of flaky. Things are semi-offline, not really fully offline capable yet. And then things don't quite work in local area networks that are never connected to the internet. So I think there are a few applications here and there that do work, but they're kind of one in between, highly tailored to a specific use case, and not really kind of like just a browser working that way or an operating system working that way. What I would love to get to is just a computer working fully in these systems and being able to move around and just have applications seamlessly operate with the computers they can see, even if they can't see everything else. The next thing is scalability. So things work pretty well when in the low orders of magnitude. I think we're now reaching millions. So IPFS is used by millions of end users. I think a number of the other applications here are as well. We're probably together as a whole pushing in the tens, maybe hundreds of millions. I would say like that's too high, probably around tens. But we're certainly very far away from billions, and certainly the trillions of devices of the future. So there's a lot of work that we all have to do to make all of these networks scale really well. So it'd be great to by DTN 3 get over here. Just for reference, DTN 1 we were maybe like over here. So we've had improvement. Let's keep going. Performance stuff has to be like super fast. I think a lot of us have been working on that, but that's just going to be a continuing thing. I want to highlight fragmentation because there's a lot of really good things that we're doing. So we have different approaches to things. We have a bunch of different experiments. We explore solutions in a bunch of different directions. And that way, as a whole community, we're moving faster. We are working on many languages and different platforms. We're optimizing for different use cases. All these different projects are going after different stuff. But the bad side of that is that we're fragmenting the web. We're like creating a whole bunch of fragmented islands of data that doesn't actually interact with each other. We're duplicating work, apps don't work well together, and so on. And so this is actually an opportunity. We can turn this into a strength. I think we need to continue using different approaches for things, different experiments, and so on. But this is a good opportunity for us to do things like protocol interop, common formats, common protocols and modules. Find like the things that we're all doing together that we should be that we're doing separately, but we should just work on together and to duplicate that work. One interesting one that I think is kind of like a small hack away is a protocol handler that just can be hooked into the browser and into OSs that just makes it really, really easy to coordinate maybe through a GitHub repo to add all the different DWeb protocol handlers to be able to launch different applications. And just kind of like a common URL scheme that will just make this easy for everybody. So yeah, we think this opportunity is to work together. I wanted to mention one thing that we've been working on that is similar to that works in this direction, and that's CIDs. This is a kind of protocol for content, protocol agnostic content addressed IDs. So this means any kind of hash link data structures can be addressed by CIDs. Really good for version control systems, really good for the DWeb, really good for blockchains. We have CIDs for all of these systems, and I think more. And that's like the ones that we've been kind of playing around with. I think all the applications on top of IPFS then automatically get CIDs. But this is something that I think a lot of other systems could use to then be able to interop and interlink with all this stuff. Yep. So security, I want to mention that we're doing well on integrity, authentication, and encryption. But censorship resistance, kind of OK. Proofs, making everything verifiable, some good parts, but not everything. Audits are kind of sparse. I've been kind of looking at a bunch of different projects and who's doing audits and who's not. And it's like, we're not great. We got to get way better at this. And perhaps getting into formal verification of some of the protocols. People are going to start using your stuff for very serious stuff, and you don't want to get them in trouble. Privacy concerns are all embedded into security, but I'll just highlight those separately. Private content is a big deal. Sharing controls that make sense to everybody, not just developers, need to be part of this. And probably, this is something that we're all doing poorly on: reader privacy, writer privacy, and oblivious routing. People shouldn't be able to correlate users and so on. And those are very difficult things. Naming, we've got DNS support, we've got ENS support, we've got pet names and so on, but we don't yet have trillions of mutable pointers that work really fast. We need to get to that. And ideally, we need an offline capable name system, something that works in those distributed environments. That's way harder, but it's necessary. User authentication. Identities as keys are good. Self-certifying names are good. DID and systems like that are good. But we don't yet have offline first user authentication that really just works. And certainly, all the user auth schemes that we've been building are not user-friendly, and they're not even dev-friendly. It is extremely complicated to build any application that tries to do something with kind of user authentication in the DWeb right now. It's just super, super hard. I think that's actually one of the blockers why we don't see a lot of applications using this stuff. It's because this user auth problem is still pretty big. Platforms, we're doing well on desktop, service, and browser. Mobile's OK. We still have a bunch of toolchain problems, and then far away from these other ones. Usability, this has been talked about many times in this conference. I'll just reference that again. This is our systems are usable by ourselves. That's good. Hey, look, at least that's good. But they're only kind of usable by other peer-to-peer devs, and only kind of usable in non-peer-to-peer devs. No way usable by savvy, just savvy computer users or anybody. I do think that there are some exceptions. I think some projects are really prioritizing this and getting good at it, at least in some use case with some communities. But as a whole, this is how I would rate the entire ecosystem. We need to do a lot better as a group. Content moderation is a big one. This was talked about many times. Why do we even want decentralization? This is a hard one. Individual choice, community choice, block lists, algorithmic filters for content. This is going to bite us really hard if we're not careful. Already a bunch of bad bits are flowing around these networks. Dynamic data, so static files, mutable files, and so on. I would highlight scalable real-time peer-to-peer apps, something that no one's achieved yet. I'm talking about Twitter scale type of activity. We need to get to something like that. If we don't get there, all these systems aren't gonna be used by mainstream users of computation. So those are great, significant challenges. Like, we have homework to do. I want us all to kind of use, let's get like at least one deep in each of these slides by next DTN. I think that would be a really great result. And slowly we'll chip away at the problem and we'll get there. One thing I wanted to throw back to the last DTN is that I showed a slide of like, hey, this is why it's called the Interplanetary File System. I want to be able to like use IPFS in Mars. I mentioned that SpaceX at the time wanted to get there in 2026. That's really soon. I showed this graph of like, the DTN at the time was 2015. This is, the time left. 5 years have passed, and we have 6 years to go. So I'm going to renew our commitment to like make IPFS work across planets, by that point. All right. So how to I want to talk a little bit about this, but I also know that this has been going on for a while. So I'm going to ask Paulo, do I have like 5 minutes? Yeah? All right, sweet. I want to talk a bit about protocol apps because one of the things that's probably the most important that's happened over the last 5 years is that we've built an organization that can do this kind of work long term. And this is not easy. Building a group that you all are parts of different groups that are doing this, so you understand how difficult it is to like work on groundbreaking new tech, for years at a time. And I want to talk to you about like why a lot of people here have asked me why we're doing what we're doing or why build an organization like this. So I just wanted to like explain how we think and why we do what we do. And so PL is interested in driving breakthroughs in computing and internet technology to push humanity forward. We recognize that computing is one of the most important things that's happened to humanity. And the DWeb is, and peer-to-peer in general, and so on, and Web3 are parts of the movement or parts of like the evolution of computing. But this is such a larger phenomenon that is really affecting the entire species and has been doing so for 80 years and will do so henceforth. And when I talk about that, people are like, oh yeah, computing is important. Cool. But there's kind of like a gap in understanding sometimes. And so I want to like, I was thinking about how to drive the point of like why we think computing is so impactful to our species. And so I want you to think about kind of the Gutenberg press and the magnitude of impact that single invention had on our species. Right? So you think of like pre-1400s development and who had access to reading and who didn't, and how frequently materials were disseminated. And the Gutenberg press is hailed as a very important watershed moment for society. And then I direct you to think about writing itself. Think about humanity before writing and after writing. Think about how much we changed in the time that we had language and oral tradition and so on, but we couldn't yet write it down. We didn't yet have laws that you could codify and kind of agree upon. We didn't have history. The word history starts after writing. You have prehistory and history. And so we have recognized writing as such an important thing, obviously much more important than something like the Gutenberg press. And I'd say then we have language as yet another level of improvement. Just think about our species before and after language. It's hard to say when language started. It's hard to say which species have what forms of language. We don't yet understand how language develops in species in general. But there was definitely a watershed moment when our species was able to communicate complex ideas to each other, and we started being able to form cultures and tribes and learn together. That was a very, very important invention in technology development and evolution, adaptation, whatever you want to call it. And what I want to say is that computing is not a Gutenberg press type of invention. It's not a writing type of invention. It's a language type of invention. And we're at the very beginning of a transcendental, totally different kind of future. And it's going to take a while for it to play out. But this is why we care very deeply about the future of computing. Where is it headed? How is it going to be used? What are people going to do with the things we're building? And you can just see, like, you can remember to some extent and read about life before and after computers, and things have changed a lot. But just think about how things are going to change over the next 10, 20 years. Things like AR and VR are coming. Brain-machine interfaces are around the corner. People are already playing around with this stuff. So these things are going to land relatively soon. And right now, there's some very important developments. Things like, I remember when we used to reflect on autonomous driving as a never going to happen type of thing. It was like 10 years ago when people were still debating, oh yeah, is it going to happen in 50 years, 100 years? And now it feels inevitable. Raise your hand if you've been in an autonomous driving car. Yeah, around 10, 12 of you. I think by next DTN, the number will increase quite drastically. We have robotics. I don't know if have you seen the Boston Dynamics videos of like all the robots? Kind of terrifying, right? Yeah, I mean that's coming. And then I think there's a lot that's been said about deep learning and machine learning and so on, but probably I think the most impactful thing happened last year when Alpha Star beat the StarCraft champions. So much more important than Go. StarCraft is an extremely complicated game, like really deeply complicated. This isn't just like I like StarCraft more than Go thing, which I do, but this is rather the kind of activity that Alpha Star is capable of doing and capable of learning, and the level of deep strategy of managing an economy and understanding how to like attack another player and harass the opponent and understand their economy and so on and deny certain kind of actions. That level of strategy is extremely complicated and deep. And the fact that we now have a software system that trained, I think, for a week before beating one of the top players and then another week before beating like the top player at the time is astounding. Like that level of quality of thinking, and I'm going to call it thinking, is really breathtaking. And it suggests that all kinds of other systems right now are now within the domain of something like AlphaStar. All kinds of traffic optimization problems. And also, hey, look, StarCraft is a simulation of armies battling each other, right? So like you just put 2 and 2 together, and you're like, oh shit, what's coming? And this is without even talking about like AI, right? So AI is like a whole other thing that experts agree is going to happen somewhere between 20 and 150 years. This is where most AI experts will say either they believe it'll never happen, which is a minority, or the majority think it'll happen sometime between 20 and 150 years. Even if you take 70 years, that's still terrifying, right? Like getting artificial general intelligence at this point, it's a pretty significant thing. So all of this is concerning, but the good news is that all of these machines, all of these systems that we're building are subject to what we do. Right now, we control, to a great extent, what we build and how we build it, and what kind of alignment we build with it. So this is why things like AI alignment are important. This is why things like ethical construction of robots is important. All kinds of very important things are happening at the moment, and it all depends on what the people developing these systems and using them, or in vicinity of them, are choosing to do. So the power is in your hands to write the future. And so understand the potential, understand the magnitude and importance, and make sure that there's a good future. So we think that there's kind of not just a possibility, but a responsibility to make sure that the future is a good one. And so that the future is in your hands, and so make it a good one. Great. So I think I'll stop there, and thank you.